Okay. Hello everyone, my name is Omar Seddati. I'm from UMONS University. I will present our approach and results in the task of retrieving diverse social images. In this work, the strategy we opted for consists mainly in 3 steps. The first step is about reranking the initial list provided by Flickr. In the second step, we remove some irrelevant images, and the final step is about diversification. So first I will explain the general approach followed for all the rounds, then I will present separately each round specificity. So the first thing we do is some feature extraction in order to have query and image representations that can be compared and used to measure similarity. Once we have these representations, we use the DBSCAN algorithm to find several clusters in the feature space. Then we sort these clusters based on the initial rank given by Flickr to the cluster centroid. Next, we make the assumption that 150 images from the list of Flickr results are relevant. Therefore, we select enough clusters from the previous list of sorted clusters to have at least 150 images, if they are available, of course. So in the next step, we start with a second clustering using the same algorithm and the images assumed to be relevant. Then we start selecting one image per cluster until we reach the last cluster. Once that happens, we start again from the first cluster until we have the 50 results. Finally, we group the images that belong to the same cluster and present the results in the cluster order. Additionally, for the last 4 rounds, we added a third clustering based on the username inside each cluster. And at each time that we are going to select a new image from a cluster, we make sure that we select equally images from different user groups. Now that I've presented the general approach, I will provide some details for each round, starting with the second round. In this round, only the use of textual information is permitted. First, we started with an evaluation of the various metadata provided for each image of the dataset. We noticed that the tags give a better representation compared to the titles and descriptions. In our approach, we use the tags of an image as a sentence. We use word2vec to encode each word in a sentence, and we use the weighted average word2vec approach to compute the whole representation of the image based on text sentence. Then we use the presentation of the query and those of all the images, and we follow the general approach presented at the beginning. For the first run, only visual information is allowed. In order to extract powerful visual features, we use a state-of-the-art approach. We start with removing the last pooling layer and the last fully connected layer of a residual network, the ResNet 50. Then we use the resulting fully convolutional network to compute the multi-resolution RMAC descriptor. Since query is in text form, we needed a way to have query representation that can be compared with the visual features. Therefore, we made the assumption that the first 3 results provided by Flickr are relevant and representative of the query. We do the first clustering of the general approach, and we select the n clusters that contain the top 3 images. We consider the distance between the query and the center of a cluster as the minimal distance between this center and the centers of the n clusters. We use this distance to sort the clusters and follow the rest of general approach. In the third round, we followed the same approach, but we concatenated the textual representation with the visual one and use this as a multimodal representation. In addition, we also used the grouping and selection by username. In the fourth round, we removed the textual representation in order to evaluate its impact on relevance compared to combining all the visual features with username clustering. In the fifth round, we used Google image search engine to download 10 images that matches the query. Then we use these 10 images to replace the top 3 images of round 4. Our aim is to build a better visual representation of the query in order to show the efficiency of the proposed pipeline. Okay, now that I presented our approach, let's move to the results. In this table, we show the results achieved on both DevSet and TestSet. We can see that the approach combining Google Image Top 10 with our visual representation and username clustering provides the best results for all metrics. For the other runs, the visual features surprisingly are given significantly better relevance than tags. The use of tags seems to enhance diversity in both DevSet and TestSet. The combination of visual and textual features achieves the best results, but these results are slightly better than those achieved by visual features combined with username grouping. To conclude, in the proposed approach, the visual feature seems to enhance relevance while the tags improve diversity, and the grouping by username is beneficial for both. The results of the approach based on Google Top 10 representation of the query indicate that we still need a good representation of the query to enhance the results of the multimodal approach. Since the query is in text form, we should enhance our textual representation for relevance. Our future developments will mainly focus on improving results relevance based on textual information. Thank you for your attention.